have my English cheat sheet here because I can't read the slides, but you guys can. So we're running a little bit late. Who wants the 10-minute version of this talk? All right, who wants the 20-minute version of this talk? All right, 10 minutes, let's wait. Raise your hand. Who wants the 20-minute version? Raise your hand. All right, everybody apparently wants the 20-minute version. I'll try. So hi, I'm Colin Dixon. I'm a distinguished engineer at Brocade, and I'm the technical steering committee chair for OpenDaylight, which means that I am responsible for all of our technical developments and have no power whatsoever to get people to actually do anything. So it's a kind of interesting job. If anybody's interested, I can tell you about it. So I'm going to talk about 4 things probably today. I'm probably going to skip the research questions. If you want to ask, you can ask later on. I'm going to talk about the state of SDN and networking. I'm going to talk about open source in networking. And I'm going to talk about OpenDaylight and who's using it. And really, I'm pretty much going to focus on one thesis, which is that the change that is happening in networking really isn't about networking. It's really not about SDN, it's really not about NFV, it's entirely about open source software. It really is the networking industry realizing that for about 40 years, the entire rest of technology has been riding a wave of open source software, and networking didn't. There are reasons why we didn't, there are reasons why it didn't happen, but now we are, and it's going to change everything about networking, and it's going to turn it into what the rest of technology has done. Okay, so most of you this should be a review. In the last 20 years, networks have changed in every conceivable way. They are bigger, they have different sets of traffic patterns, they have more endpoints, the endpoints move more often, and despite all of that transition, network gear and the way you run networks really hasn't changed at all. We have had the same managing one device at a time, we've had the same standard way that you get in, you log in, you configure things, and nothing has really shifted except that we have faster boxes. So what really needs to change, and this is all going to be about software, is we really need to move from doing device-by-device setup to doing network-wide orchestration. You've heard about OpenO already, you're going to hear about OpenO again next. Orchestration is real, it is huge, and it is all about software. We need to move from using open standards to open standards and open source. And I actually am going to argue that open source is going to trump open standards for everything except for where you need to be interfacing with hardware. The place where you need open standards is you need them with hardware, so that way hardware vendors have longer cycles to be able to develop their hardware and don't have as much churn as you get from software. And everything is moving from proprietary to open source. I really am enjoying seeing how much open source is happening in China. I believe that SDN open source and open source software is going to, the vast majority of it in the next 5 years, the innovation is going to come from China. And I'm excited to see it starting, and I want to see more of it. I'm on WeChat. If you can find me on WeChat, and we should talk, but I want to see more developers showing up in OpenDaylight and anywhere else in open source, please. And then we're seeing this shift from individual silos to everything being all together, which is we're not going to have storage, compute, and networking separate. It's all going to be software. It's all going to be the same set of open source software pieces that you're going to be putting together. And so really, this is the shift, it is the rise of open source software. It happens to be hitting networking late, and it's going to have more impact. All right. So everybody knows how OpenFlow works? Raise your hand if you know how OpenFlow works. Okay, well, we'll go through this quickly. I'm an engineer, so I actually build things, so I like to show people how this stuff works. So traditional networking, when a packet would come into a device, it would get forwarded in the data plane, which is a very special purpose hardware box, and that would basically do a lookup on a table, figure out what's in the packet. And then, as part of that, you might actually learn something about the network by seeing how the packets flow. So in this case, you learn where the address OA was. In OpenFlow and traditional SDN, instead, you have less and less of the activity happening on the switch itself. It migrates up into a controller where you can do fancier things. So when a packet comes in, rather than, say, sending it directly to handling it on the switch, it can be handled by the controller. And so you can do anything you can imagine doing and install the rules to appropriately handle in the future. So this is a very specific understanding of SDN. It involves moving the control plane off of the box. This, I still believe, will happen. It is really exciting and interesting. It gives you a lot more control over your network. I think we radically underestimated how hard it was to make this real. And how long it takes to build a replacement control plane in a controller. And the result is, I'm sorry, then it sends the packet out. The result is that what I think is real today and what is happening is what I call sort of modern inclusive SDN. And this recognizes the real problems that we have today are not really about the control plane being in the wrong place. The problems we have today are we don't have network-wide control, and we don't have the ability in order to innovate independently at different layers. And so that's really represented here where you have multiple different vendors. You have, not only do you have no way to do the innovation you really need, which is across boxes, but you have to buy into one individual stack. So you can't pick and choose and get best of breed. And so the right solution to this problem isn't, strictly speaking, separation of control plane and data plane. It's about disaggregation and about using common open interfaces. And so modern inclusive SDN, you pull the management plane off of all of the boxes, the control plane off of maybe some of them, and you use standard control protocols in order to speak to the different devices, and standard modeling languages in order to define your interactions when you have to, and you provide as best you can the northbound interfaces people actually want at the top. And so this diagram, I think about it in terms of OpenDaylight, but OpenDaylight plus OpenO, SDNFV, they all sort of fit into this ecosystem of some control plane centralization, some management plane centralization, some orchestration, and some set of northbound interfaces. This is really, I think, this is what people actually want. It's what you can actually build today, and it's what OpenDaylight and the other open source organizations are trying to build. So it's, again, it's really more about openness and disaggregation, not about control plane and data plane separation. So open source. I'm going to talk about OpenDaylight in detail tomorrow. You should come to the talk. So I'm going to focus today on open source in general, but a little bit less about OpenDaylight. So here's a whole bunch of open source projects you've probably heard of. I'm going to add OpenO to the list. These slides, OpenO didn't exist when I had these slides made and translated, and I haven't had time to have new slides translated, so that's why OpenO is missing. But add OpenO to this list as right next to OpenStack. I've called out 3 important ones. OpenStack and sort of OpenO are some other ones at the orchestration level and focus on sort of broadly managing your entire IT infrastructure. There's a set of controllers. OpenDaylight is one, ONOS is another, Ryu is another. OpenVSwitch is a good example of a data plane, but there's lots of others. There's the FD.io project, which is new from Linux Foundation. There's a whole bunch of different pieces in this space. And really this slide is less to shout about any particular one, but just show the raw number of open source projects that we have in networking. Networking is going through a renaissance, a golden age of open source. There are more open source networking projects than you'll deal with. The biggest problem you're going to have is picking the right ones to use, not that there isn't something that does what you want to do. I think Dan Pitt alluded to that. Paul alluded to the fact that we have too much code. The hard part is figuring out what code to go grab, not there being enough code. So why do we care about open source? This is really, I think, the crux of what's going on. There's 4 key reasons why I think people care about open source. The first one is, and this is usually what comes up first, is avoiding vendor lock-in, getting cheaper gear. This is the idea that if you have open source, you don't have to worry that it's Cisco gear or it's Huawei gear, and it will always have to be that. The second one, and this is a little bit less well known, is you get to have a seat at the table. Open source software is built, designed, architected in the open. And that means that even if you're a customer, you can get the open source code, you can participate as it's being built. Not just getting the code, but actually participating in the creation of the code. You don't even have to write it, but just OpenDaylight, for example, has an advisory group where we invite all the people that use OpenDaylight to come and tell us what's important to them, what doesn't work for them. We have a huge number of Chinese companies on our advisory group. China Mobile, China Unicom, Tencent are all on our advisory group, and we'd love to see more participation and more engagement. It gives you faster innovation, and for two key reasons. One, the more people you have at the table, and the more different people you have at the table, the faster innovation you get. But second, because it is open source and can be modified, you don't have to wait for other people to deliver the innovation that you need today. I think that's the killer app of open source, which is if you need a feature today, you can go build it today. You don't have to wait for Brocade or Cisco or anybody to ship it to you 6 weeks from now, or 6 months from now, or a year from now. You can build what you need today. And lastly, interop and integration. This is not to be discounted. And it's not just the fact that open source is built on a common code platform, though that helps a lot. It is also the fact that when you buy open source software, you use open source software, the people from different companies who work on it know each other. So as a result, for example, if Brocade and Sienna and Tencent want to get together and do something, they have engineers that know each other and actually have interacted together and know what beers each other drink. So you can actually go get useful things done via phone calls and emails instead of having conversations via trouble tickets and via open bugs. This is really the heart of open source. You'll note sort of one thing I didn't really say here, which is cost. Every time I end up talking to people about open source, it's usually cost is the first thing. I'm going to be pretty honest. I don't think open source saves money, at least in the short run, and maybe not in the long run. I think it's a different value proposition that you get out of open source. It is not about cost savings per se. It's mostly about something else entirely, which is about agility. So traditionally, you had two choices to how to get software. You either had to build it yourself, or you could buy it from somebody else. And what open source has done is it's opened up this whole spectrum in between the two endpoints, where you can choose how much you want to build versus how much you want to buy. And generally speaking, cost stays relatively flat as you move back and forth. And the reason is because, and I'm going to try and make sure I have the order of this right. The reason is because it tends to be the case that ease of use is better when you buy. Tends to be more polished, tends to have more people call for support, cheaper to operate. More expensive to buy because you have to pay for it, but cheaper to operate. On the other hand, and really the reason why it is that people use open source is for agility and flexibility. It's the ability to do really exciting new things quickly is much, much, much easier if you build it yourself than if you buy it. And open source has enabled us in order to pick sort of points in that spectrum, which are more interesting than just all the way at the left or all the way at the right. So if you're curious about, if you want, you can buy open source from a vendor with support. You can buy some of your stuff and use open source for others. And that really wasn't possible until open source started coming to networking. So really, this is what I think SDN is about, and NFT is about. I don't think it's about the technologies. I think it's about this freedom and flexibility to go buy or build or extend or modify software that is open source. It's not about the underlying networking technology. It's about the way that we're building networking technology now, and not as hardware, not as proprietary hardware, but as open source software. This is what this transformation is about. This is what's going to change the world. So this is a comparison of open source and open standards. I'm going to skip those two slides because they're not particularly interesting. So OpenDaylight. I have got a little bit of OpenDaylight in particular as an example. OpenDaylight is a Linux Foundation open source project. It has three main goals. One is the production of code to actually provide open SDN solutions. The second one is adoption, getting people to actually use the code. And the third one, and this is the part where it is that I think is actually the most important, is community, which is that OpenDaylight wants to build the biggest and the most useful community of SDN-engaged people. And I think that that is exactly the biggest value that OpenDaylight has provided, is in this community. The architecture is relatively simple to draw. We have the core OpenDaylight is the MD, the model-driven service abstraction layer, or MD-SAL. It has 3 different things. It has data, more procedure calls, and notifications. It can be clustered, so that way you can have multiple different copies of it and scale out or get high availability. Applications run on top, and plugins run on the bottom. In reality, everything runs on the top, though. There is no difference in an application and a plugin. It just happens to be for logical reasons we draw them that way. And everything inside of it is modeled in a language called Yang. This is really, really useful because it makes it extensible and easy to build more stuff on top of. And I'll go into more of this tomorrow in my talk about OpenDaylight itself. This is the Lithium architecture. We actually have a Beryllium architecture that's out since then. You can scan this now. We'll have a Beryllium one tomorrow. This slide's just a little bit out of date. So I want to pause for a second and talk about community, because I think this is really the biggest part of OpenDaylight and really the biggest part of the Linux Foundation. OpenDaylight, this is a picture taken from a Hackfest in San Jose a while ago, but the community is really what's driving OpenDaylight and what's making OpenDaylight the place to be, and what's helping the Linux Foundation drive open source, which is that we have hundreds of developers from all over the world working on this. And I know that there are hundreds of developers in China that are working on this, and I want to see more of you. I know because I talk to you every time I come here, but there aren't as many of you that actually participate and ship the code back. So please, please, please come and actually engage as broadly as you can. Let me know what I can do to help. Here are some numbers. We have something like, running something like 200 commits per week. We have something like 600 developers these days. There's just a huge number of people working on OpenDaylight, and more show up every day. So please come. We'd love to have you. We'd love to help you solve your problems. So find me, and we can talk about that. What do people use OpenDaylight for? Pretty much everything, but I'll just highlight a couple. Telstra is using OpenDaylight to provide wide area network connectivity between their data centers. This is something that actually Tencent is also using. AT&T has built out a huge amount of their domain 2.0 effort on top of OpenDaylight. Bandwidth on demand in particular is the biggest one that they're currently rolling out. Although they have announced somewhat cryptically that there's going to be a service launched in 29 countries in the same day or something. So based on OpenDaylight, and we'll see how that goes. CERN, which runs the Large Hadron Collider, uses SDN and OpenDaylight in particular in order to distribute all of their data. And then lastly, in this slide, we don't say, but Tencent is using OpenDaylight incredibly hugely. They're using it for the data center interconnect, they're using it for network virtualization, they're using it for orchestration, and they're really doing amazing things. And so, really, we have an amazing champion for OpenDaylight and for open source networking in China, in Tencent, and I'd love to see everybody, people start to learn from that. So I'm going to skip these last 2 use cases, and I'm going to leave you on a slide of how to get involved. This is what OpenDaylight is about. It's about the community. So here's where it is that you can find wikis, you can find the code, you can find mailing lists, you can find meetings. Everything is open as it gets. Even the technical steering committee meetings that I run, anybody can talk. You can listen, you can talk, you can show up. It's at a really bad time for China, and we're working on trying to fix that. We're actually talking about having 1 meeting a month in a time zone that works with China, and we've been thinking about that for some time. So please come, get involved, ask questions, and we would love to have you. Thank you.